Welcome back, Union High School Pre-Calc. We hope you are doing well. We are going to be looking at geometric sequences and series. This is the last lesson of this week. You'll have 2 My Math Lab assignments after this one, as well as a Google form check-in with your teacher. Remember that all homework this week is due Friday at 9 p.m. And also a reminder that next week is actually our last week of distance learning, so you'll have your second and last assessment next week. All right, let's get started. A little recap from last time. Remember that arithmetic sequences and series are when you add a common difference d to find the next term. And we found out last time that if I want to find the nth term, I start with the first term and I would add my common difference n minus 1 times. So if I want to find like the 99th term, I would start with the first term and add my common difference 98 times, okay? We also found, thanks to Gauss, that if I want to sum up the first n terms, I figure out how many pairs I have, so I take n divided by 2 times the first term plus the nth term, okay? So that was when Gauss took like 1 plus 2 plus 3 all the way to 100, okay? Remember that arithmetic sequences are very analogous to linear functions. Okay, and today we're going to be looking at geometric sequences and series. And you guessed it, geometric is when you multiply a common ratio r to find the next term. So we are going to be looking for a formula for the nth term, as well as the sum of the first n terms, and something unique to geometric sequences is sometimes they can have an infinite sum, okay? And just like arithmetic sequences are analogous to linear functions, geometric sequences are analogous to exponential functions, okay? All right, well, let's get started here. Let's dive right in and see if we can find a formula for a sub n for geometric sequences. So I'm going to start with my first term. Geometric sequence means I'm multiplying the same number each time. So the second term is going to be my first term times whatever my common ratio is, r, okay? And my third term is going to be the previous term times r, but remember I can make the substitution. I know what the second term is in terms of a1, right? So I can say that the third term is actually a1 times r, and I still have this other times r, so a1 times r squared, which makes sense, right? If I want to find the third term, I would start with the first term and multiply r 2 times. Similarly, the fourth term is going to be the third term times r. But again, I know what the third term is. The third term is that. So I can make that substitution, a1 times r squared times another r. So to find the fourth term, I would take a1 times r cubed. Okay? All right, so what if I want to find the 8th term? I would start with the first term, a1, and then times r 7 times, right? If I want to find the 100th term, it'd be a1 times r to the 99th. So in general, if I want to find the nth term, I start with my first term, a1 times r to the n minus 1, right? Okay. So let's practice that. Find the 7th term in the following sequence, 2, 4, 8, 16. We can see that this is geometric because I'm multiplying the same number each time. I'm multiplying 2 each time to get to the next term. All right, so remember our general formula is that I want to find the 7th term. So anywhere I see an n, I'm going to plug in 7. a1, the first term is 2. We said r was also 2, right? And then I'm going to have 7 minus 1, or 6 here. And that's going to be 128, and all of this is calculator active, okay? All right, so what if I want to take that a step further and actually find that sum? So what if I wanted to find s sub 7, the sum of the first 7 terms? Okay, well, let's see if we can figure out that formula. And unfortunately, I don't have a cute Gauss story to go with this. Let's see if we can derive it. So let's take S sub n, that would be the first term, plus the second term, plus the third term, all the way to the nth term. But I'm going to write it with our formula. We know the second term is a1 times r. The third term is a1 times r squared. And then the last term would be a1 times r to the n minus 1, right? Okay, now for my second line, what I'm going to do is take that first line and just distribute r all the way through to every single term. So I'd now have a1 times r plus a1 times r squared plus a1 times r cubed, dot, 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 dot. And now the last term would be a1 times r to the n, right? And what would, by the way, what would the term right before that be? Be that, correct? Okay, so now let's do this. Let's subtract the two rows, basically doing that, okay? What's going to happen? Well, these guys cancel, right? As do these. This one would have canceled with the next one over here. And then the last term here cancels with the second to last term here. So all you have left on the top row is a1 minus the only thing you have left on the bottom row is a1 times r to the n. Okay, how does this help? Well, let's take a look at the left-hand side of this equation and factor out an s sub n. So that's what I'm trying to solve for, right? Just to stick with textbook notation, I'm going to factor out my a sub 1 on the right-hand side. Okay, so now if I want to solve for s sub n, I just need to divide both sides by that expression 1 minus r. Whoa, and that is our formula for the sum of the first n terms in a geometric sequence, okay? So that's important. Obviously, when you're taking your assessments and homework, you're going to have access to notes. So for right now, these aren't formulas you need to memorize, but you do want to have them all handy and together here, okay? All right, so let's practice this. Find the sum of the first 7 terms in the geometric sequence 10 plus 40 plus 160. Okay, let's take a look at this formula. We have a1 times the quantity 1 minus r to the n all over 1 minus r. Okay, all right, so do we know a1? Yep, that is 10, right? Do we know r? Yeah, we're multiplying by 4 each time. And what is n? N is 7. So if I want to find the sum of the first 7 terms, that's going to be the first term, 10, times the quantity 1 minus 4 to the 7th, all over 1 minus 4. And I'm being really pretty picky with parentheses here because this is going to be important, especially if r is negative. And from here, you can plug it into the calculator just like that, and you're going to get 54,610. Okay, let's try one more. What about sigma notation? Something like this. Find the indicated sum. How do I know that this is geometric? Well, take a look at your expression inside the sigma. Notice that that is an exponential function, right? And what's your base? It's 1/2. So that's going to be your r. How would I find my first term? Well, plug that number into k. You get 1/2 to the 1, which is also going to be 1/2. Okay? And if you don't believe me, we can always write it out. So let's see if this would be 1/2 to the 1 plus 1/2 to the 2 plus 1/2 to the 3, right? So you can see I've got a geometric sequence with a1 being 1/2 and r being 1/2 as well, okay? So I want to find the sum of the first 3 terms. Remember, we start with a sub 1 and then 1 minus r to the n, which in this case is 3, all over 1 minus r. Okay, so I've got 1/2 times 1 minus 1/8 here, right? So that, oh goodness, is going to be 7/8 over 1/2 here. The 1/2s cancel, so I'm getting 7/8 here. You can still do that on a calculator. Whatever is faster. All right, so where are we going with this next? Remember, we have one more kind of nuance with geometric series, and that is that sometimes you can actually find an infinite geometric series. In other words, you take this infinite sequence and you keep adding and adding and adding terms, and you actually hit a limit, okay? So let me show you kind of a graphical picture of this particular series. So I have 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16. So my A1 is 1 and my R is 0.5. Okay, so there's A1. There's my second term. Third term is 0.25, sorry. Fourth term. Fifth. What's happening? I'm adding more and more and more and more terms, right? And I'm getting closer and closer to filling that area. But we're never going to exceed that area, right? So we say that the infinite sum exists, and that in this case it's 2. Alrighty? So here's kind of a similar example. In this case, if I didn't have that 1, if I had 1/2 plus 1/4 plus 1/8 and so on, we would say that 1 is the limit of this series. So 1 is the sum of the infinite geometric sequence, and it's denoted by S sub infinity. Okay? All right, so question and answer time. Will all infinite geometric sequences have a sum? If so, why? If not, give a counterexample. What do you think? All geometric sequences will not have a sum. For example, what about that one we were doing earlier, 10 plus 40 plus? If that just keeps going and going and going, the sequence goes to infinity, the sum in this case will as well, right? So what has to be true about the common ratio for the sum of an infinite geometric sequence to exist? So what a lot of students tell me here is R has to be a fraction, which I understand what they're saying, but what about this fraction? If R is 2 over 1, would that work? Yeah, so let's be really specific here. R, the absolute value of R, needs to be less than 1, right? So between -1 and +1 will work for us here, okay? All right, let's try and let's find the formula for S sub infinity here. So for S sub infinity, what is going to happen to R to the n as n approaches infinity? Well, let's take R to be like 1/2 again. If I take 1/2 to a really big number, you can put that in your calculator. That's going to 0, right? If I take 1/2 times 1/2 times 1/2 times 1/2, it's getting smaller and smaller. So what happens as n approaches infinity, this piece is going to go away. That's going to go to 0. So I have a sub 1 times 1 minus 0 over 1 minus r, which is equal to that. Okay, so my formula here, and this is the last one I'd like for you to write down, is S sub infinity is just the first term all over 1 minus r, okay? And notice that this is actually simpler than the S sub n equation, right? Okay, try a couple examples here. Find the sum if it exists. I'm going to put this as reference here. So I need the first term and I need r. So in this case, the first term is 45, and my r value, what am I multiplying by each time? Yeah, so I'm dividing by 3, which is the same as multiplying by 1/3, correct? So we've got 45 over 2/3, which is the same as 45 times the reciprocal, 3/2. So 135 over 2. Okay. What about b? Is that geometric? Yes, because you're seeing that exponential expression. What is r? Remember, that's your base. And can you figure out what your first term is? I'll plug that number in here. So you get 0.4 to the 0, which is 1, and then 1 times 5 is 5. Okay, so my infinite sum is 5 over 1 minus 0.4, which is 0.6 in the denominator, right? 0.6 is 6/10, which is 3/5. So if I want to divide by 3/5, that's the same as multiplying by 5/3. Okay. All right, what about that last one? It is geometric, but what is r? R is pi, which is greater than 1. So this series diverges, is what we say. That diverges, the others converged. Okay. All right, last one. Can you prove that 0.999 repeating is equal to 1? Okay. Well, 0.9 repeating can be written like this. 0.9 plus 0.9 times 0.1, right? That would get me that part. Plus 0.9 times 0.1 squared. That would get me that. And so on and so forth. So my first term is 0.9, and what is r? What am I multiplying by each time? 0.1, right? So my infinite sum will be my first term over 1 minus my common ratio, which is 0.9 over 0.9. Anything over itself is 1. Yay. Okay. All right, friends, you've got a couple homeworks to check out. Don't forget to do your check-in with your math teacher, and then everything will be due 9 p.m. on Friday. We'll talk soon.